Okay, so today we're going to graph this function, and we're not going to be able to graph this perfectly like we did yesterday with Desmos, but we'll be able to get a rough sketch, kind of like we did on Tuesday, but we're going to include a little bit more detail on Tuesday. So here's the different things we want to find before we graph. We want to find the zeros of the function, which you want to remember that another name for that would be roots, or x-intercepts. And we want to find also the y-intercept of this function. So these are the two things that we are going to find for this function. So if I go through, the zeros of this function would be, well, I want to think about what makes this equal 0, which would be 0. What makes this equal 0, which would be -5. And what makes this equal 0, which would be -3. So my zeros would be 0, comma, -5, comma, -5, comma, -3. And again, we write that -5 twice because of that little square term. Now let's graph that on the coordinate plane. So 0 would be here, -5 would be 1, 2, 3, 4, 5, and -3 would be 1, 2, 3. So everything kind of happens on this side right here. The next thing we're going to do is we're going to find the y-intercept. Hopefully you remember from before that the y-intercept means that x equals 0. So I'm going to take this equation and we're going to plug in 0 for x. So I'm going to have y equals 0, x or 0 plus 5 squared, and then 0 plus 3. Well, that's going to end our day very, very quickly, because 0 times anything makes this whole thing to get 0. So our y-intercept in this case is 0, which would be right there. So our y-intercept happens to be one of our zeros of the function. That doesn't always happen, but it does sometimes. We'll see an event where it doesn't happen in the next example. So let's try to graph this thing. Now when we graph this thing, here's the decisions we're making. We're going to decide if the function's going to do this, or if the function's going to do this. If the function's going to do this, or this, this, or this, this, or this. So we got to decide basically at every stage whether it's positive or whether it's negative. So we're going to use this thing to decide that. Well, I'm going to take a number that is, our smallest number is like this section right here. So we're going to just take a number that is less than -5 and plug it into here. So I'm going to choose -6. Well, if you take that and you plug -6 in, so we're going to plug -6 into here to kind of see what that does. So I know a -6 will become a positive, so that first thing will be positive. If you plug a -6, well, anything squared will always be positive, and then that will be a negative. So if you take these things and you all multiply them together, this thing is negative. So this was the correct symbol. So I'll go over here and I'll erase this side right here, because it didn't happen to be positive. So here's the sketch that I made so far. I know it was negative in that first interval. Now I don't need this 6's. We got to decide now between our next two zeros, which would be between here and here. Whoops, made that pretty fat. But between here and here, so between -5 and -3, whether this thing is positive or negative. Well, the only number that's in between there is -4. So we're going to plug that in to all our spaces. And when we plug -4 into there, It's going to change this part up over here, so let me get rid of that. What would happen would be negative 4 would be a positive. Well, anything squared becomes positive, and then this last one, negative 4 plus 3 would be a negative. So we have a positive times a negative. That gives us a negative again. So this, at this stage, was the correct one. So again, we'll erase the part we don't need, or we found out we don't need, so I don't need this right here. Okay, so now we got to make the next decision for this spot right over here. Whoops. So that spot is between -3 and 0. So we got to pick a number between -3 and 0. I'm going to pick -1. So let's get rid of that. And what we would find would be that if I plug in -1 to all of these spots, that we would get a positive. Anything squared will give me positive. And then this one right here, -1 plus 3, will give us a positive. So they're all positive this time, so we got our first positive example. Hooray. So let's get rid of this other thing over here. So this negative side I don't need. And it kind of loops up here. So let's draw that a little bit better. So it loops, whoops. It loops and it's going to connect there. So now we just have one last thing to decide, which would be this back here. So it's what happens after we get to 0. So I'm going to pick a number that's after 0. So let's pick this time 1 and decide what's going to get erased. So we're going to pick 1 this time. So when I plug in 1, I should get, well, that'll give me a negative. This will give me a positive, and this will give me a positive. So negative, positive, positive will give me a negative. So say goodbye to the positive side again. And if we look, whoops, I always forget to change my eraser off. If we look, this would be the rough sketch of our graph. It starts out negative, which is what we found. It bounces again and it's negative, then it finally flips to being positive, and then it flips back to being negative. So this polynomial right here makes some kind of looping shape like that, with its y-intercept being here, and a 0 being there, and a 0 being here, and a 0 being here. We're going to look at one more where we have a different y-intercept, but I'm not going to go through and graph the whole thing. Okay, if we look at the zeros of our function, this one should give me -3. This one should give me -2, and this one should give me 1 twice. Now let's find the y-intercept again. The y-intercept means that x is 0. So we're going to take that function and plug in 0 for every x that we see. Well, what's that going to do is we have to do the parentheses stuff first. So 0 plus 3 is 3, 0 plus 2 is 2, and 0 plus -1 is -1. And then we have to follow order of operations. So we're going to deal with this squared first. So we'll have -3, 2, and -1 squared is 1. And then when we multiply all this, we'd have -3 times 2, which would give us -6, times 1 would give us -6. So our y-intercept this time will be that y equals -6. Okay? And again, we could go back up here and graph all of these, like graph these 3 y-intercepts. So our rough sketch, or our zeros, and then graph our y-intercept. So our rough sketch this time would look like this, with my zeros being in purple. So -3, -2, and 1. And then my y-intercept being in green, which would be down here at -6. So we would need to figure out how this thing goes. It makes it a little bit easier because you know between this 0, it's got to do something like this because it's got to hit the y-intercept. So we know it's going to go down. But we'd have to figure out for this area whether it's a plus or minus, this area whether it's a plus or minus, and this area whether it's a plus or minus. So try to graph these things today. Try the different problems.